What is the value of genomics for our stud breeder? This is one of the questions that we'll be answering today with Jason Redding from SA Stud Book. Jason, thanks for joining us once again. Why should stud breeders choose genomics for parentage verification?
Thank you for having me today. Why should stud breeders use genomics for parentage? Well, stud breeders adopted DNA technology for the verification of a sire or a dam. That's in essence what stud breeding is, ensuring that the pedigree is correct, and using DNA technology ensures that there is pedigree integrity. They first started off with blood groups. We know A, B, and O type blood, but that wasn't the best that they could do. Then they introduced DNA microsatellite technology, which is currently the most used form of parentage verification in South Africa. But one must keep in mind that DNA microsatellite technology is not a parentage verification. It is actually an exclusion of who is definitely not the parent and only gives an indication of who can possibly be the parent. On everyone's report, they know, dit kan moontlik die pa wees. This could possibly be the sire. It is not confirmation. So the DNA microsatellite uses 12 to 20 markers. And when you use highly related bulls, like half-brothers or a father-son combination on your farm, tested calves will test positive against both of the bulls that are highly related. And then the breeder must look at his records to choose which sire was with that dam or just choose one, which plays against that whole thing of pedigree integrity. Genomics, which is a newer technology and is actually the standard internationally, we in South Africa are a bit behind, uses 15 to 25,000 markers. And this is confirmation of parentage. We are accurately identifying who is directly related to each other. You cannot pick up multiple sires using the genomic technology. Why else it is good is that you can discover the true sire. The genomics is able to pick up who is directly related to each other. We also use a very stringent threshold of 1%, meaning that if only 150 to 250 of those 15,000 markers are not in concordance with each other, that's a flag. And only the genomics can confirm parentage, while DNA microsatellite is a possibility of parentage.
What are single genes and how do they work?
Oh, single genes. That's a big buzzword in the industry at the moment. Let's think about DNA. The DNA that you have consists of two strands of DNA. The one that you got from your father and the one that you got from your mother. So you can only get one copy of DNA from your parent and one copy from the other parent. Single genes are specific markers that influence a phenotype without the environment actually affecting the expression of these phenotypes. So because you get one copy from your mom and one copy from your dad, that means that there are only three possible combinations: a 0, a 1, or a 2. If it's a 0, you got both of the same copy from your parents. If you are a 1 or a heterozygote, you got one copy from your dad and a different copy from your mom. And if you're a 2, you are the other homozygote copy. You got the same from your parents. The easiest example is the horned poll expression in beef cattle. This is controlled by a single locus known as the polled locus, and the variant we give is the Celtic variant. So all the cattle that you see out there that are horned carry two copies of the horned gene, meaning that they got one from their dad and one from their mom. This acts recessively, meaning that it must have both copies for you to see the phenotype. But then researchers saw that some of the animals don't have horns. So they identified this polled gene, and they see that the animals who carry the polled gene are polled. But the polled gene shows dominance over the horned. So an animal that is polled can either be PH, or the heterozygote, meaning it got the polled from its sire and the horned from its dam, or it can be PP, double polled or a polled homozygote, and it doesn't matter what that gene is passed on to whatever parent, to progeny, it will always pass on the polled gene because it only has those 2 copies. So breeders can ensure that they have a good polled bull or a bull that is polled homozygotically, and all the calves from that bull will be polled, even if it is mated with a horned. Because you've got 2 P's and 2 H's, only the P will pass on and only the H will pass on, but that animal will still be phenotypically polled because the polled is dominant over the horned. There are a lot of other single genes, and they mainly work in this fashion, but there are such things as additive as well as over-dominance effects that we also see in some of the single genes.
To get back to the value of genomically testing animals, what benefits can a breeder immediately get?
Well, we've just discussed parentage and single genes. So parentage verification and discovery is one of the immediate benefits, as long as the parents themselves are also genomically tested. Unfortunately, the genomics is not backward compatible with the DNA older technology, the microsats. So there's first that. Second, single genes. We can see what is the carrier status of your animals. Is it a double homozygotic polled bull? Does it carry the double muscling mutation like the N2A21, Q204X, and F94L, which are known to not be positive mutations, especially if you want to breed replacement heifers, not have birthing problems, and have longevity within your animals. The other ones are milk mutations, such as the DGAT1, which is very widely known in the dairy industry to increase butterfat production. We're having a look at that in the beef cattle. We've got meat tenderness genes, culpane and culpostatin, that facilitate the conversion of muscle to meat post-slaughter. We're also having a look at that, as well as any detrimental or recessive genes within populations. The big ones at the moment are the glycogen storage diseases, which come from Brahman ancestry. So any composite breed or admixed breed with Indocene ancestry could potentially carry this, and we see that. And lastly is breed purity. At SA Stud Book, we have a tool we call the breed key, which is quite a complex model that we've developed to calculate how related is your stud animal to the rest of the stud population. So you can see if your animal is actually indeed 90% or more related to the stud population. Is also a good tool for breeders that are upgrading from nondescript cattle to a specific stud breed to see, are they actually making progress within their upgrading from the nondescript towards that stud animal at the rate at which they desire.
Jason, I think if there was any doubt, that's been cancelled. Thank you very much for your information this morning. Jason Redding from SA Stud Book, explaining the value of genomics.